Hello and welcome to Easy Maths. In this video, we're going to focus our attention on the area of tangents and circles. We're going to particularly be focusing on the area of a tangent to circles. And so, let's begin. Now, tangent to two circles. This area is going to be tackled using 4 videos, and the first video will be to do the direct common tangents, followed by an extended example of the same area, and then we're going to have another one on the case of a transverse or tangents which are intersecting, and an example on that. And therefore we're going to have 4 videos, and so this is the first one of such videos. Now, as we begin, we have before us 2 circles with center O1 and O2. We have PQ and TU, which are common tangents to the circles with centers O1 and O2, as it's seen there, PQ and TU. Again, we understand, or we know at this point, that the angle between radius and the tangent of a circle is always 90 degrees. We say that in a previous lesson, like the angle between O1 PQ and the angle between O2 QP, they're both 90. Again, if we have our point R such that PR is equals to QO2, understand that QO2 is the radius of the smaller circle. Now, if we have the same radius measured from P towards O1, such that we have the point R like this, so RP and QO2 are equal in length, and therefore they are the radius of the smaller circle, then we'll have, or we can complete a circle like this, such that the line RO2 is a tangent to the circle, small dotted circle like that, and therefore that means that the angle PRO2 is 90 degrees again. Again, we can draw an equivalent tangent like the one we have there. Now, if we have this point R such that PR and QO2 are equal, then RPQO2 is a rectangle. And I should say that that's the major idea in this lesson. That is a rectangle there. We are forming a geometrical figure so that it helps us in calculating the distance around. If the circle center O1 and O2 were, say, gears, and PQ is a belt that goes to the 2 pulleys or 2 gears like it's seen there, and then UT and all that, so that we have a distance going around like that, we can look for the distance there if we use this geometrical figure RPQO2. And now that I need to prove that RPQO2 is a rectangle, let me say the following few things. That RPQO2 is a 4-sided figure. Obviously we can see that it's a 4-sided figure, and we know that all angles are 90. The reason that all angles are 90 is because the angle between the tangent and the radius of a circle is always 90. So the angle at P is 90, the angle at R is 90, the angle at Q is 90. That means in a 4-sided figure whose internal angles should add up to 360, 3 of them are 90, and that means it's 90 times 3, which is 270. The last one should also be 90, so that we have a total of 360. And therefore, essentially, PQO2R is actually a rectangle. But some additional concept relating to that. Please notice that we've said PQ is equals to QO2, so the PR is equals to QO2. Again, notice that PR and QO2 are simultaneously perpendicular to PQ. That is this distance here and this distance here. They are perpendicular to PQ. We have said that. Now, PR and QO2 are also perpendicular to RO2. Let me say that since PR and QO2 are simultaneously perpendicular to PQ, it means that PR and QO2 are parallel. Now, again, because PR is perpendicular to RO2, it means also QO2 is also perpendicular to RO2. And so that's why I'm saying this statement here, that PR and QO2 are also perpendicular to RO2. And of course, we now know PQ must be the same in terms of length to RO2. So this distance must be the same as this one, simply because PR and QO2 are equal in length and simultaneously perpendicular to both PQ and RO2, we can actually say that the distance PQ and RO2 are also equal in length. And therefore we say that the four-sided figure that RPQO2 must have two equal sides, or two pairs of equal sides. That means a parallelogram, and all angles are 90, therefore it's a rectangle. And I hope that proves to you. But of course you can see that without having to say all of these things here, since the angle at P, at R, and at Q are 90, it means the last angle should also be 90, and that qualifies that to be a parallelogram, and not just a parallelogram, a unique parallelogram, that is a rectangle. Now another concept we should also know is that if we complete the diagram so that we have an equivalent of P01, O2, Q below here, such that we have T01, O2, U like that, and an equivalent of R, which is the point S. So we have SO2 is a tangent to a small circle with center O1, this broken circle here. So if we have the same geometrical figures below here, therefore we also know that STUO2 must be a rectangle as well. So STUO2 must be a rectangle. The reason is the angle between a tangent and a radius is 90. So at S is an angle of 90 degrees. At T also is an angle of 90 degrees. At U is an angle of 90 degrees. That means the four-sided figure STUO2 has four angles, has four interior angles which are 90, and therefore it's a parallelogram and actually a rectangle. And therefore we can say that it's actually a rectangle. Now the other thing we should also know is that the obtuse angle PO1T, so PO1T must be equal to the obtuse angle QO2U. The reason I'm saying that is because when a student knows this angle here, this angle P01T, then the student should also know that should be the same as QO2U. So you don't have to look for one angle when you have the other. Let me prove that to you. Now RO1O2, if that angle RO1O2 is 70, that RO1O2, if that angle there is 70, then we know the angle below it, that is SO1O2, must be 70, and RO1S should be 140 because it's 70 times 2. Remember in a previous tutorial we said that tangents to tangents that meet outside a circle in exterior, like the point O2, tangent to the small circle with center O1, that is this broken circle here. The two tangents RO2 and SO2 meeting outside normally form similar figures or angles, RO1O2 and SO1O2. So for that reason, the angles RO1O2 and SO1O2 must be 70. Adding together, you get 140. Now that means that RO2O1 is 20. That means we have an angle of 90 at point R. We have an angle of, say, the point O1. That means that angle in that triangle, that is the angle at O2, that is the angle O1O2R, must be 20 degrees. Similarly, SO1O2 should be 20 for the same reason. If that's the case, therefore, the reflex angle QO2U, that is QO2U, the reflex angle this side here, should be 90 plus 20 plus 20 plus 90. The reason is we have 90 here, we have a 20-degree angle, we have another 20-degree angle, we have another 90-degree angle, which equals to 220. And that therefore means that the obtuse angle QO2U, the one we have been talking about, QO2U, should be 360 minus the reflex angle we just got in there. That is 360 minus 220, and therefore the answer will be 140. And that tells you that what we said at the beginning, that the obtuse angle PO1T and QO2U, they are equal. So if you know one, you don't need to calculate the other one. You already know that. Now, this brings me to the end of that particular lesson. Please check out for the next video, which has an example that has all these concepts considered and tied together. Always like, subscribe, and share. I'll appreciate it. Thank you.